Hello students, I am Gurmeet Singh. Welcome to CREATA classes and also welcome to the 8th lecture of the probability series. Yes, this is the probability series and this is the 8th lecture. In this lecture, we will take down question number 21 to question number 25. The link to rest of the video are given in the description. So without taking any further time, let's take down our question number 21. Here it is. A lot consists of 144 ball pens, of which 20 are defective and the other are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and give it to her. What is the probability that, in the first case, she will buy it, in the second case, she will not buy it? So let's observe the question. The question gives 144 ball pens, out of which 20 are defective. It means that 144 minus 20, that is 124 pen are good. Total pens are given as 144, which includes 20 defective pens. So we got 124 good pens. And Nuri came to the shopkeeper to buy the pens, and she will not accept the defective pens. As usual, nobody accepts a defective pen. So what is the probability that if the shopkeepers randomly takes out one pen, will it be acceptable to Nuri or not? It means that if the shopkeeper randomly takes out one pen, if it is good, then it is acceptable to Nuri. If it is not good, it is not acceptable to Nuri. In the first case, we have to find the probability that she will buy the pen. It means that in the first case, we have to find the probability of getting good pen. Got it? And in the second case, we have to find the probability that she will not buy the pen. It means that we have to find the probability of getting the defective pen. So we have observed the question. Let's take the standard formula of the probability. As usual, we will start with the denominator. Let's identify the possible outcomes, the total possible outcomes. In this question, total 144 pens are given. So the total outcome will be these 144 pens, which includes 124 good pens and 20 bad or the defective pens. So in the first case, we have to find the probability of good pen. So in the numerator, what will be the favorable outcome? The favorable outcome will be good pen, which are 124 good pen. So this 124 good pen will come in the numerator, as these are the favorable outcomes. We got the probability as 124 over 144, which is 31 by 36, which is the answer of the first part. Second part, we have to find the probability of the defective pens. We can use the two approaches to solve this question. Firstly, let's take the first approach. In the first approach, we can directly use the formula. In the denominator, we got 144, and in the numerator, we will have the favorable outcome, which are defective pen. So we are having 20 defective pen, 20 will come in the numerator, 144 is already in the denominator. We got our answer as 20 by 144, which is basically 5 by 36. Got it? We could have solved this second part using the different approach too. The approach is that we can use this formula, that is PE plus PE naught is equal to 1. Here the event is the good pen. So can we say the probability of good pen plus probability of not good pen is equal to 1? Yes, we can say so. And here the probability of not good pen is basically the probability of defective pen. We have just rearranged the wording. Okay. So in the first part, we have got the probability of first case as 31 by 36. So we can easily calculate the second one as 1 minus 31 by 36, which is 5 by 36. Our answer is matching, so we can use either of the two approaches. But you should know each and every approach, so in the mid of the exam, you will not be in the trouble. So we have done with the question number 21. Let's move to question number 22. The question 22 is having two parts. Let's take the first part. Refer to the example 13.1. Complete the following table. A table is given. Firstly, let's observe the question number 13 that we have done in the exercise part. The link to the exercise question is also given in the description. If you want to go to the detail, check it out, the link in the description. So in the question number 13 of the exercise, the two dice are thrown simultaneously and we have got 36 output. These are the 36 output that we got by rolling two dice simultaneously. And we have done the addition of the two numbers that we got from rolling of the die. For example, one in the first die and the one in the second die, we got the addition as 2. Similarly, we have done the addition of all the 36 number. We have got various numbers like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. The maximum number that we got is 12 because the maximum that we can got on the die is 6 and 6. That is 6 plus 6 is equal to 12. And the minimum that we can get on rolling the die is 1 on each die. So the minimum addition is 1 plus 1, that is 2. So we got the addition from number 2 to number 12. And coming back to this question, we have to fill the table. On the first row, the event sum is given. Here this is sum 2, here this is sum as 3, sum as 4, up to sum as 12. We have seen the minimum sum that we can get is 2 and the maximum sum that we can get is 12. In the second row, we have to calculate the probability of each addition. Some of the probabilities are given. So let's calculate the probability. So as per the formula of the probability, on the denominator it will be the total outcome. Here we are getting total 36 outcome. So in all these cases, the denominator will remain same, that is 36 cases. So 36 will remain the denominator in all the cases. Let's start with the first, the addition as 2. We are getting only one case where addition is 2. So in the numerator, we will only get one case. So the probability is 1 by 36. Let's take the second case, that is the addition as 3. We got 2 addition as 3, so the probability is 2 by 36. Let's take the case number 4. We got 3 total cases where the addition is 4. So the probability is 3 by 36. Similarly, for the addition 5, 4 cases, probability is 4 by 36. Addition as 6, total cases 5, so the probability is 5 by 36. 7, here the number of cases are 6, so we got the probability as 6 by 36. 8, the total number of cases are 5, so it is 5 by 36, which is already given. Addition as 9, total case 4, 4 by 36 is the probability. Similarly, the addition as 10, we got 3 cases, 3 by 36. Addition as 11, 2 cases, 2 by 36, and addition as 12, only one case, that is 1 by 36 is the probability, which is already given. So now you can solve any of the question in which we are throwing 2 dice simultaneously. And we have also completed the table. So we have completed the part 1 of the question number 22. Let's move to the part 2. A student argues that there are 11 possible outcomes, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has the probability 1 by 11. Do you agree with this argument? Justify your answer. Here in the part 2, a student argues that there are 11 possible outcomes of any of the experiment. You can take this experiment of die. That is, we are getting 2, 3, 4, 5 up to 12. These all are the outcome. We can also compare this with the case of the die. That is, we are getting total 11 output from the addition 2 to addition 12. So the student is saying the probability of each event or each output is 1 by 11. So the student is thinking that we are having total 11 output. So in the denominator 11 will come. and each case is coming only 1, so we will get 1 in the numerator. For example, if we have to calculate the probability of 2, so the student is thinking 2 is coming only 1, so 1 in the numerator and total 11 case in the denominator. So we got 1 by 11 as the answer. This is what the student is thinking. But this approach is not correct. This approach of getting 1 by 11 as the probability is not correct. Why? Because in the question it is given these are the output. Means we can get the addition or the output as 2, 3, 4 up to the 12. But how many times these outputs are repeating is not given. For example, in the case of die, the number 3 is repeating 2 times, number 4 is repeating 3 times. So these outputs may repeat, and as per the repetition the numerator will change, and as per the repetition our total output will also change. We can take an example. Suppose we are getting these output. Here we can say the possible outcome are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is matching with the scenario in which the student is calculating the probability. But here 2 is repeating 2 times, 3 is also repeating 2 times, like 6 and 12 are also repeating 2 times. So if we have to calculate the probability of number 2, here in the numerator we will get 2 because 2 is repeating 2 times, and in the denominator we will get the total addition. So here the probability is not 1 by 11. So the argument made by the student is not correct. Are you understanding why it is not correct? Because the possibility of each output is not equal. Some outputs are more as compared to other outputs. Let's move to question number 23. A game consists of tossing a 1 rupees coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So this is the question. So let's observe the question. In the question, 1 coin is given, that is 1 rupees coin, and this coin is tossed 3 times. And we are getting 3 different outputs each time, like head and tail in the first case, head and tail in the second case, and head and tail in the third case. And one game is played by the Hanif. If the Hanif got all the 3 outputs same, for example head 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 or tail tail tail, he will win the game. Otherwise he will lose the game. Otherwise means all the 3 outputs are not same. Before proceeding, let's check out how many outputs we will get. We are having 1 coin and it is tossed 3 times. So we are having 3 slots. In the first slot, we are getting 2 output, head and tail. In the second, again 2 output, and in the third case, again 2 outputs. So if we use the simple fundamental of principle of counting, or and or principle, we will get 2 into 2 into 2, that is total 8 cases will be available. Okay, we are tossing the coin 3 times, each time we are getting 2 output, so we will get total 8 cases. How we have done this? The same we have covered in the lecture of permutation and or principle. Check out the lecture or the video on our YouTube page. I will put the link in the description. That is very interesting lecture. So let's move further and let's check out what are the various 8 outputs or the 8 cases that we can get. We can get all these 8 cases. If you observe all these 8 cases, we are having one case as head 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 and one case as tail tail tail. Only in these 2 cases Hanif will win, and in all the other cases Hanif will lose. And we have to calculate the probability of losing of Hanif. In other words, we can say we have to find the probability of getting these 6 output. In the 6 output or in the 6 cases, Hanif is losing. Only in the 2 cases, Hanif is winning. So basically, we have to calculate the probability of these 6 cases in which Hanif will lose. So let's use the formula of probability. In the denominator, we will get the total number of cases, which are total 8 cases. And in the numerator, the favorable outcome are these 6 cases. So 6 will come in the numerator and 8 will come in the denominator. We got 6 by 8 or 3 by 4 as the answer. That is probability of losing of Hanif. So we have done the question number 23. Let's move to the next question. A die is thrown twice. What is the probability that in the first case 5 will not come up either times? In the second case 5 will come up at least once. Firstly, let's observe the question. Here in this question we are rolling 2 dice. So we are having 2 dice. In the previous questions also we have done the similar type of cases. We got all these 36 output when we roll the 2 dice. Got it? In the first case, we have to find the probability when 5 will not come up either times. Firstly, let's see in which of the cases we are getting 5. In all these cases, we are having the number 5 when we roll the die. In the first case, we have to calculate all the cases where 5 will not come up either times. It means that 5 is not in any of the 2 output or any of the 2 die. So we can say all these cases are satisfying our first condition. That is, all these cases are not having the number 5. So in the first case, all these cases will come. In the second part, 5 will come up at least once. So all these cases are satisfying our second condition because these cases are having the number 5. The first part include all these cases and the second part include all these cases. Now let's use the formula of probability. For the first case, we are having total 36 output that will come in the denominator. Let's see what will come in the numerator. These number are total 11. We are having total 36 output. 36 minus 11, it means these all are 25. So in the numerator, we will get 25 outputs that are the favorable cases. So we got the probability as 25 by 36. Got it? In the second case, 5 will come in the 11 cases. So we got 11 in the numerator and 36 in the denominator. We got the answer as 11 by 36. We can also use the alternate approach, that is the probability of event plus probability of not event is equal to 1. We have already calculated the probability of not 5 as 25 by 36. So we can use this formula and also get the same result as 11 by 36. So we have also approached this question through alternate approach. Let's move to the next question, which is the last question. Question number 25. Which of the following arguments are correct and which are not? Give reason for your answer. First, if 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 head, 2 tail, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. Let's observe the question. 2 coins are tossed simultaneously. It means that we will get head and tail as the output from both the coin. The question framer is saying that it has 3 possible output: 2 head, 2 tail, or 1 of each, that is head tail. But this understanding is not correct. If we roll the 2 coins, we will get total 4 output. That is head head, which is given in the question, tail tail, which is also given in the question. But after that we will get head tail or tail head. It means total 4 outputs will be there. So the understanding in the question is not correct, or we can say it is false. Further, it is given the probability of each event will be 1 by 3. If we are getting 3 outputs, then we can say it is 1 by 3. But here we are getting 4 outputs. So the probability of each event will be 1 by 4. So the first is incorrect or false. If a die is thrown, there are two possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. We know we have done the various cases of die and we get total 6 output from the dice. So rolling the die is having 6 output. But the question framer is saying that when rolling the die we are getting two possible output, that is either odd number or even number. Yes, this understanding is also correct. If we are rolling the die, we are getting the number from 1 to 6. We can segregate the number in terms of even and odd. That is 1, 3 and 5 will be the odd number and 2, 4, 6 will be the even number. So we can say when we are rolling the die, either we are getting the odd number and we are getting the even number. So this understanding is purely correct. Further, the probability of getting the odd number is 1 by 2. Let's check it out. Let's use the formula of probability. We will start with the denominator. We are getting total 6 cases. So 6 in the denominator, and in the numerator we are getting total 3 odd numbers. So the probability is 3 by 6 or 1 by 2. So the understanding in the question is purely correct. We can also approach in the alternate ways, that is we are having two events, odd and even. In the denominator it will be odd plus even, that is two outputs, and in the numerator we have to find the probability of odd event, that is 1. So we get the probability as 1 by 2. Just for your understanding, we can use either of the approach. We will get the probability as 1 by 2. So this second part is true. First is false and second is true. We have completed all the example question and all the exercise 15.1 question for 10th math class. If you want to check out the video, check the video in the description. The link is given in the description. After this video, we will have a revision video. That is very important. You can use a revision video like one day before the exam or whenever you want to do the refreshing of the probability series. Note that we will not only cover the basic concept, but we will also cover some of the question. But we will go very fast because that is the revision series and we do not want to waste your time. Whenever you want to do the revision, whether for your 10th board exam, any of the competitive exam in which you want to do the probability brush up, just check out the revision video. You do not have to do all the complete 8 videos. So that's it for this video. Thank you very much. Meet you in the next lecture. Bye bye.